Next up is laws of motion, which I would say is one of the most important chapters. I mean, if you would ask me, tell me the name of some chapters that you can skip and appear to the exam, and tell me those chapters which you can never skip. I would say the number one, top of the list, would be laws of motion. That's something that you can never ever skip, irrespective of which exam it is. Let it be your NEET exam, let it be the AIEEE, the JEE Mains, the JEE Advanced. You cannot skip this chapter. Such is the relevance and significance of this. Having said so, let's just move on to the topic. Let us not waste time here. So, an explosion breaks a rock into three parts in a horizontal plane. Two of them go off at right angles to each other. The first part of mass 1 kilogram moves with a speed of 12 meter per second, and the second part of the mass 2 kilogram moves with a 8 meter per second. If the third part flies off with 4 meter per second speed, then its masses. Okay. So, before going through the question here, let us first try to understand what is given to us. See, let's try to picturize this. So there's a condition here, initial condition, the rock was at rest, and then we have a final condition. Okay, so the mass was so the rock was at rest. Let us call the rock of mass m. At rest means the velocity is equal to 0, right? And then finally what happened is, this rock exploded into three parts, right? This exploded in three parts, and one part out of this, suppose, goes like this, and the other part went in the perpendicular direction, and the third one could move in any direction. Now see, one problem with this question is it has not been given that it's going in right angles in which axis. It's only given a horizontal plane, which can be any plane. So what I'll do is I'll assume that this is the xy plane. This is the xy plane. So we have is one part going like this, other part is going like this, third one is going like this. Okay. So this is part 1, part 2, and part 3. What is the characteristics here? It is m1 v1. Characteristics here is m2 v2, and this has m3 and v3. Now let us try to understand the concept here. Okay, the first part of the question, the concept here, which is that for a system, if the F external acting on it is equal to 0, then it means that the rate of change of linear momentum, I repeat, the rate of change of linear momentum is equal to 0. Okay. Now see, what we need to understand is the primary condition here is that F external should be equal to 0. Now that is where the significance of this first sentence comes. An explosion breaks a rock, right? So it's an explosion, which means this rock being exploded implies that there is no external force acting on it. Explosion is coming from the within, which means it is very safe to assume that F external here is equal to 0. So this is one of the most important concepts here. Students usually don't try to understand this, and they just start solving the numerical, but they don't give emphasis on this. I repeat, explosion comes from forces within the system, right? And that's why we can safely assume that F external is equal to 0. And if F external is equal to 0, what does it imply for the momentum? If F external equal to 0, it implies for the linear momentum, I repeat, for the linear momentum, that the rate of change of linear momentum d by dt of p, rate of change of d by dt of linear momentum of p is equal to 0. What does this imply further? Simple. See, d by dt of 2 is equal to 0. In the same way, d by dx of 4 is also equal to 0. D by dy of 6 is equal to 0. Or in other words, the rate of change of a constant is equal to 0. rate of change of a constant is equal to 0. Now the other way around. If d by dt of p is equal to 0, it overlaps with d by dt of a constant is equal to 0. So if the rate of change of linear momentum is equal to 0, it otherwise means that the linear momentum is a constant. Therefore, I can say that linear momentum is a constant. Excuse me. So when you have linear momentum as a constant, it implies that momentum initial should be equal to momentum final. Or in other words, momentum before explosion should be equal to momentum after explosion. I hope that makes sense, right? Okay. In this case, what is momentum before explosion? See, that would be mass of the rock, big rock, into velocity. What is momentum after explosion? We have three parts here, right? So I'll write it like this: momentum vector 1 plus momentum vector 2 plus momentum vector 3. Okay. Now assuming this to be in the xy plane. See, this is where the vector approach becomes really important in this question. So say drawing the xy axis for our reference, okay? So this is positive x, this is negative x, this is positive y, and this is negative y. So when we say that the first vector and the second vector are mutually perpendicular, I can assume that it's like this, and the second vector would be like this, right? Because they are perpendicular to each other. And if I write that, can I mention this as vector p1 and this as vector p2? And we don't know where is vector p3 located. Okay, we don't know the angle, we don't know which coordinate it is. It can be like this, it can be like this as well, it can be in any direction. Let us assume that it's going like this. Now, what is this vector v? It is at rest, so that is 0 into what is p1? P1 is actually m into vector v1 plus what is p2? It is m into vector v2. What is p3? It is m into vector v3, right? Now, what is p1? M into 0 is 0. The first mass is given us to be, first part of mass 1 kilogram, right? So this is 1 kilogram moving at 1 kilogram is moving at 12 meter per second. The other is 2 kilogram is moving at 8 meter per second. So I can write here 1 kilogram moving at 12 meter per second, which is 12, of course, but most importantly, this should be j cap, right? Plus ms, sorry, m1 and m2, right? Okay, and m3 here. So m2 is 2 kilogram into 8 meter per second. Along which direction? This would be along the positive I cap direction. Plus, do we know m3? We don't know m3. So this is m3 into v3, right? Now, so this takes us to 0 is equal to 12 j cap plus 16 I cap plus m3 into vector v3. Okay. So if I write this one more step, what is m3 into vector v3 is equal to? M3 into vector v3 is equal to minus 12 j cap minus 16 I cap, right? Now I'll take magnitude on both sides. Magnitude on both sides. So what do we get? This would become m3 into magnitude of vector v3. I repeat, m3 into magnitude of vector v3 is equal to magnitude of minus 12 minus 16, which actually is equal to root of 12 square plus 16 square. Now, What is magnitude of velocity? Magnitude of velocity is actually nothing but speed, right? Magnitude of velocity is nothing but speed of 3. So we have speed of 3 is equal to root of 12 square plus root of 12 square plus 16 square, which is nothing but root of, so we have 144 plus 169, right? Sorry, 16 it is, so it is 256. 10, 5 plus 5 is 10, so it's 400. So it's root of 400, which is equal to 20. So we have m3 into, what is speed of 3? It is given directly in the question that the third part flies off with a 4 meter per second speed. So it is 4 is equal to 20, and therefore m3 is equal to 5. So let us go to the question once again. What is the concept? The concept is that if f external is equal to 0, then it implies that the rate of change of momentum, which momentum? Linear momentum is equal to 0. And what does it imply? It further implies that the momentum should be a constant. And what is that gives us in turn? If the momentum is constant, it implies that momentum before explosion should be equal to momentum after explosion. And then we have the vector approach. And see, you can also confirm one thing from here, that the vector v3 is having both minus j and minus I, which means it should be in the third quadrant. So this assumption is actually correct. Okay, right. So we can also figure out one more thing here. If we were to take this resultant here, resultant of 1 and 2, what we get is root of p1 square plus p2 square. So if you see that the resultant of 1 and 2 is actually balanced with the third momentum vector, right? So that's also one concept that you can derive it from here. So we've done the explanation of the concept, we've done the numerical, and we've also done the analysis of the result. Right, so that's it. Let us move on to the next question.